Hello. So we're continuing on Chapter 5, Section 1. So we introduced a couple of things, just as a summary. We introduced what angles are and how to construct them. You basically start with a ray, rotate that ray a certain amount. You get a second ray like that, and then that distance or that area between that original ray, which is called the initial side, and the final ray that you got after rotating, which is called the terminal side of the angle. That is how you create an angle, right? So that area in between is your angle. Okay. Now, we ended up talking about the XY plane. So I gave you a very quick summary about how the XY plane works and why it's useful. For us, it's going to be useful again because we're going to be embedding our angles in the XY plane, which is going to allow us to work with coordinates in our angles in our rays. So if we want a ray that goes through the origin and through the point 3, -1, like I have here, now that we have the XY plane, we can do that more explicitly. Instead of just drawing, rays in just random white space like I was doing before. Right? So it's kind of going to make our work a little bit more precise. Okay? And it's also going to allow us to use algebra when we work with our angles. And you'll see how that's going to work in a moment. Okay? So let's see what definition 3 says. So an angle theta is in standard position. Let me underline that. If its vertex is in the point or is the point 0, 0, the origin in the XY plane, and its initial side lies on the positive x-axis. Okay? So how does an angle in standard position look like? Okay, so basically, we draw an XY plane again. And in this case, I'm not going to draw the dashes, just for this particular example. But again, remember that the horizontal axis for our purposes, unless stated otherwise, is always going to be the x-axis, and the vertical axis is always going to be the y-axis. Again, unless stated otherwise. So let's say I want to draw an angle in standard position. Right? So how can I do that? Well, based on the definition here, I want the vertex of the angle to be at the origin. Right? So I know that the vertex of the angle is going to be here. Remember, the origin is where the x-axis and the y-axis cross. The other condition that we need is that the starting position or the starting side, initial side of the angle starts on the positive x-axis. Right? So this angle is going to have an initial side and a terminal side. So just make sure that the initial side is on the positive x-axis. Right? So let's say this is a 45-degree angle. And I mentioned how, when we were talking in the previous video, how a 90-degree angle. How a 90-degree angle just means that you're looking at perpendicular lines. Right? So say I want to draw a 90-degree angle in standard position. Right? So I need the initial side of my ray, so my initial ray, to go in the direction of the positive x-axis. Right? So that's my initial side. Now I rotate a quantity of 90, or I want to find an angle of 90 degrees. So let me not talk about rotations yet. I'm going to do that in the next slide. But I know that my angle has to give me perpendicular lines, and I know that that's going to look something like this. Right? So my terminal side, in this case, is going to be in the positive x-axis. This is my terminal side. So this angle, this area in between, that's my angle. So let's call that angle theta. So theta is and I'll say degrees now, but I'll explain what they are in a moment. Theta is a 90-degree angle in standard position because its initial side lies on the positive x-axis and its vertex is at the origin of the xy plane. Now, you don't really have to worry about degrees yet. I just use 90 degrees because I know most people know what that means, right? It just means perpendicular lines. But you don't really have to have a specific angle measurement. So say I want to create a smaller angle than this. I still want it to be in standard position. Right? So I know that my vertex is still going to be at the origin, at the point 0, 0. And let me label the axes here. And for it to be in standard position, I also need the initial side to be on the positive x-axis. Now, in this case, I'm going to move clockwise, right? So in the previous example, I moved counterclockwise, right? Because my initial side was on the positive x-axis, and then basically I moved in this direction. So I'm going to do the same, but I'm going to move in the clockwise direction. And it doesn't matter in which direction you move, it's still in standard position. The only two things you have to check is that the vertex lies on the origin and that the initial side is on the positive x-axis. Okay. So let's say I want to do a smaller angle. Let's call it alpha. And say that angle, this goes all the way here. Right, so I rotate it in this direction, now clockwise, and now I have this angle alpha here. So let's use, I already used green, let's use yellow. This is the angle alpha. Okay. Now, sometimes, and I think they do this in the book, they might do something like that just to make it clear what the angle is. Right now that we are only working with one angle at a time, I haven't been doing it, but as soon as we start working with more than one angle, and we're going to be doing that, we're going to be embedding more than one angle in the XY plane, I'm going to start labeling my angles like this, just so it's clear what angle is which. Okay. But again, this angle here now is also in standard position. And this is usually how we're going to draw our angles, right? So from now on, unless stated otherwise, if I tell you to draw a angle, with this particular measurement, and we'll talk about degrees in a moment, then you're always going to start it with the vertex in the origin and the initial ray or initial side in the positive x-axis. And then you're going to move clockwise or counterclockwise, depending on whether you want your angle measure to be positive or negative. Okay. So let's move on. Now we're going to talk about measurements of angles. Okay. Now, obviously, if you see what I did here, every time I do this rotation, so I start with my initial ray or my initial side, and I do some sort of rotation, well, there's obviously a quantity associated with that. So the angle I'm labeling as just that area between the initial side and the terminal side. However, there are some things going on. There's obviously a rotation measurement, right? And there's also a direction measurement, and I've mentioned both, right? So I mentioned that you can move clockwise or counterclockwise. That's the direction measurement. And there's obviously a measurement for rotation, right? So for example, just looking at these two pictures here, it's pretty clear that the angle alpha, in terms of how much rotation we did, well, there was more rotation going on there than with the angle alpha. The angle theta has the one here above, had a larger rotation than the angle alpha that I drew here. Right? You can see that just from the picture. Right? So it makes sense to talk about how do we measure angles? How do we say that one angle is larger than the other? And also, how do we account for that direction? How do I make a specific distinguishment between whether I'm moving in clockwise direction or counterclockwise direction? Right? So we're going to do that here. So first of all, the measure of an angle is just, like I mentioned, this value that quantifies the amount of rotation and direction when you rotate the initial ray. Okay? The unit of measurement that we're going to be using for angles is degrees. Okay? Now, I'll say a couple things about degrees after I talk about some things here. However, I already mentioned, for example, how 90 degrees look like. Okay, so a rotation of 90 degrees, right, in the counterclockwise direction, right? And that's what the next note is going to be about. How do you distinguish between clockwise and counterclockwise direction? But a 90-degree rotation of an angle in standard position, or just a 90-degree angle in standard position, if we were to draw that, right, so basically the same thing we did before, draw its vertex at the origin. Its initial ray is on the positive x-axis. And then its ending ray or terminal side is on the positive y-axis because I'm moving counterclockwise. So it's going to end up here. So the angle in between, so this space here is going to be my angle. Let's call it alpha. And here alpha has an angle measurement of 90 degrees. Okay. Now, I haven't explained how these degrees come from yet, but I'm going to do it later because it's actually easier to first understand or explain how do we account for the direction? How do we know whether our angle happened in counterclockwise motion, like it did in this case? So oops, let me use a different color. So in this case, I moved counterclockwise. How do I distinguish that from clockwise motion? And the explanation is very easy. If your angle is measured in counterclockwise motion, so the way I did here, then your angle measurement is positive. Right? So that's why I wrote that alpha equals 90 degrees. However, if you move in the clockwise direction, then the angle measurement is negative. Right? So the magnitude of the angle is going to be the same. And let me give you an example of that. So let's say I want to draw a 90-degree angle, but now I want to do it in the clockwise direction. So again, we draw the XY plane. The vertex is at the origin. The initial side is on the positive x-axis. Oops, sorry, it's a little bit bad. Initial side is on the positive x-axis. And now I'm going to rotate in the clockwise direction. Right? So following the direction in which a clock moves. Right? So now I'm rotating this way. I want it to be 90 degrees. Right? So my terminal side is now going to be here. And the angle is just going to be the space in between. This is going to be the angle theta. And here theta is equal to not 90 degrees because we moved in clockwise rotation. So instead, this is going to be negative 90 degrees. And that's basically what that means. If you ever see an angle measurement and it says it's negative, so like in this case, theta equals negative 90, all that means is that you move the same amount, right? So the rotation, in terms of how much you rotate, is the same. The only thing that changes is the direction. And that's what I mean when I say that the angles alpha and theta have the same magnitude. Right? The amount of rotation is the same. The only thing that differs is the direction. Okay, so that's how we're going to be measuring the rotation, the direction, and then the rotation we're going to be measuring with degrees. Okay? So let me talk a little bit about degrees and give you some couple common angles. Right? So I already gave you a common angle of 90 degrees, negative 90. Let me give you a couple more. Right? But first, why do we use degrees and how this works? Right? So basically, if you draw again the XY plane, there are a couple things you can say when you're working with degrees, or actually some facts that I'm just going to give you. So I'm going to draw an angle. So I have the initial side on the positive x-axis. Now, let's say I want to do a full rotation, right? So I want to do a rotation that starts on the initial side like always. It moves all the way and comes back all the way to my original spot. So that means that my initial side and my terminal side actually both lie on the positive x-axis. So let me kind of try to draw both colors so you can see both of them. Well, that one full rotation in terms of degrees corresponds to 360 degrees. Right, so let me write that here. A full rotation like this corresponds to 360 degrees. Now from this we can do some observations. Right? Obviously we know that the XY plane is naturally broken up into quadrants. Right? So from algebra, the quadrants were quadrant 1, quadrant 2, quadrant 3, and quadrant 4. How do I draw 4? Like that. Now if you look at the angle measurements, so let's say I'm starting again with an angle in standard position. So let's say that I want to do just 90-degree rotation in the counterclockwise direction, so positive 90 degrees. Then we already know what that looks like, right? Our terminal side is going to be up here. And this here is going to be 90 degrees. Now, if I wanted to rotate now from here, so now this angle here wouldn't be in standard position, so let's call this angle theta. So now let's say I want my initial side to start on the positive y-axis. So this is not a angle in standard position anymore, right? But hopefully this will cross into you what I'm trying to say. So now my initial side is going to be this blue vertical line, and my terminal side is going to lie on the negative x-axis. If I look at that rotation there and call that angle alpha, let's call it alpha. Now, if you notice here, even though alpha and theta, so this is going to be, so yeah, so let me write it like this. Even though alpha and theta are kind of occurring in different places because one is in standard position and the other one is not, just by looking at the picture, it's kind of obvious that the measurement for alpha is still 90 degrees. And that's going to be the same if we go now from our initial position at the negative x-axis and move to the positive y-axis. Right. So now if I do that, this angle here, let's call it, let's call it beta. This angle beta is also 90 degrees. And the same if I go from beta back to the, so from the negative y-axis as the starting or initial position or side, all the way back to the positive x-axis. So if I do something like this and call this angle alpha, this is obviously again 90 degrees. Right? So what's going on here is that naturally we kind of break up this one full rotation into 4 90-degree angles. And that's one way you can kind of interpret or explain why there's why one full rotation corresponds to 360 degrees, because one 360 rotation corresponds to 4 smaller 90-degree rotations. Right? And that's something that's very useful for us. Right? Now, one thing to say here is that this unit of measurement, and we'll see this more when we talk about how to work with degrees, minutes, and seconds, basically this all goes back to the Babylonians and their units of measurement. Right? So we can take them for this and for working with minutes and seconds. Right? But that's basically the idea. Right? We have a one full rotation being 360 degrees. Just from knowing that and looking at how the XY plane looks, we know that these smaller angle rotations that I do going from each axis to the next, from positive x, positive y to negative x to negative y, and negative y to positive x, all of those angles are also 90 degrees. Okay? So it's one observation. And one thing that's going to be very useful for us for geometric interpretations and for simplifying our work. Okay, now I'm going to do one more thing before I stop this video. I'm just going to give you pictures of common angles. Right? So I already showed you the 90-degree and standard position. Right? So common angles in standard position. Right? So I already gave you a couple. I gave you 90 degrees and 360 degrees. So let's do a couple more. Another natural one that arises just from looking at this picture is a 45-degree rotation. Right? We know that 90 degrees is going from one axis to the other axis. Well, 45 degrees is right in between that. Right? So it's pretty obvious to see what a 45-degree angle in standard position is. So again, always your initial side. Now my terminal side, I want it to be 45 degrees. So I know that I have to go half the distance as 90, right? And I'm making the angles positive, so I'm moving in the counterclockwise rotation or direction. And this angle here is the angle theta, and in this case, theta equals 45 degrees. Now another common angle, let's say that I go 90 degrees twice, right? So I go from the positive x-axis as my initial position and have my terminal position or terminal side on the negative x-axis. Well, just by looking at this picture again, that's just going theta equals 90 degrees, then going alpha equals 90 degrees, and that's 180 degrees. So if I want to draw 180 degrees, I know that's going to be 90 twice. So draw your initial side, and then now you're going to draw your terminal side in the negative x-axis. And I know that's 180, again, because of this picture above, because I know that the theta rotation is 90, and then the alpha rotation is 90. Oops. So I have this rotation, again, counterclockwise. And now my angle here, let's call it, This is just the same variable here. I should just collect theta again. So in this case, theta is equal to 180 degrees. Another one, let's say I want to go 90 degrees 3 times. So I want my initial side to be on the positive x-axis and my terminal side to be on the negative y-axis. Okay. Well, if you look at our picture here again, that corresponds to going theta equals 90 degrees, then moving alpha equals 90 degrees, then moving beta equals 90 degrees. Add all of those up, and that corresponds to 90 plus 90 is 210 degrees, sorry. Yeah, 90 plus 90 is 180, so 270. Oh my gosh, yeah, so 270 degrees. Okay. And again, just using these observations that we have from the previous picture. Okay, so let's do x, y. Again, the initial side. Terminal side, I want it to be on the negative y-axis. Counterclockwise rotation, and again, based on the picture that I drew above, I know that this angle is 90 plus 90 plus 90, which is equal to 270. So it's the angle theta, and theta here equals 270. Right? So now you have 4 common angles. Right? You have 45 degrees, 90 degrees, which I drew here a bunch of times, but in standard position, just the one in the first quadrant. You know 180 degrees, which I drew, where did I draw 180? 360. We know 360 degrees, which I kind of drew here. It's kind of hard to see, so let me just draw it one last time. But that's basically one full rotation. And you also know 270 degrees and 180. Right? So we're going to start with these. There are other common angles that we're going to be working with, but for now we're just going to work with these ones. That's a sort of introduction. So we do kind of do purple here around the same side, okay? Then we have this rotation. Again, counterclockwise because it's in a standard position, right? So the initial ray is in the positive x-axis, and then here our angle theta is 360. Okay. So these are the first common angles that we're going to be working with. These ones are very easy to remember. Again, so basically you just have to remember either that the whole circle is 360 degrees or that just one quadrant is 90 degrees, and then you can derive all of these angles just from that, and just by drawing this picture here. Okay, so I'm going to stop this video here.